So this problem is pretty typical of what you would see for a Newton's law of heating and cooling on an FRQ. It's a differential equation. You may even see a slope field at the beginning of this type of problem. But this will often be both A, B, B, C subscore. So you will be able to commiserate with your fellow AB friends. At time t equals 0, a boiled potato is taken from a pot on a stove and left to cool in a kitchen. The internal temperature of the potato is 91 degrees Celsius at time t equals 0, and the internal temperature of the potato is greater than 27 degrees Celsius for all times t greater than 0. So just means that probably the room temperature is 27 degrees. The internal temperature of the potato at time t minutes can be modeled by the function h that satisfies the differential equation dh dt equals negative 1/4 h minus 27, where h of t is measured in degrees Celsius and h of 0 is 91. Okay, that's a lot of information. Here we go. There's nothing in that I don't see anything that we need to focus on necessarily in those directions. So let's start with the problem and see what we can get. Write an equation for the line tangent to the graph of h at t equals 0. Use this equation to approximate the internal temperature of the potato at time t equals 3. I am going to try to write in here, so I'm going to write smaller. Yeah, pretty small.
Just zoom in really big.
Yeah, so on this one, what do you need to write an equation of a line? Slope and a point. Where am I going to find my slope?
In the derivative equation.
At the derivative. So your first step on this would be to take dh dt and substitute in t equals 0. So we get negative 1/4 0 minus 27.
91.
Ht is 0. Sorry.
It's all right, Miss Wilson. It's Saturday.
That's all right.
It's
Oh my
Saturday.
goodness.
We get it.
Okay. Negative 1/4 of 91 minus 27, because the
It's math.
yeah, h is 91. Okay. So if we plug this in, we would get negative 16. Yeah? So that's h of 0 is 91. We know that. So we've got a slope and we have a point already. I would leave this in point slope form. Y minus 91 equals negative 16t minus 0.
Do you need
X.
Do they count out for X?
Should Y be H?
Yeah, why should then when I be?
Yeah, see, I mixed it up too. You're good. Yes, y should be h. It should be.
What I did was I wrote it in point slope and then I rewrote it in
Yeah, I
y
don't-
and X plus B
I
with
don't-
H's and T's.
I don't think you would have a problem.
Okay.
I don't think they would mark off for that.
A lot of people would do that.
I'm guessing just by the nature of this, most people will write y equals mx plus b. I did. Use the equation to approximate the internal temperature of the potato at time t equals 3. So we would just plug in t equals 3. So negative 16 times 3 is negative 48, right? 91 minus 48 would be 43.
Yeah, man.
So that's t equals 3. So h would equal 43 degrees Celsius.
Oh yeah, units, guys.
I don't know if they'll grade on units on this one.
Okay, good for you then.
Just be careful, just in case.
Okay,
How do you write?
now,
Look, she wrote degrees. Celsius degrees.
it's super not accurate. Probably they just write
Celsius
degrees. They just write degrees Celsius.
Instead of Celsius degrees.
Or just C, just a capital C would be fine.
What of Celsius?
Use
It's so embarrassing.
You're not in chem anymore, you finished.
It's done. It's gone.
Use the second derivative to determine whether your answer in part A is an underestimate or overestimate of the internal temperature of the potato at time t equals 3.
Wait, how many points for the first one?
Oh, let's do points. Let me find points.
Yes.
They give you more room to write out work, don't they?
So you know, like that test I gave you where it had the boxes?
Yeah.
That's what it'll be like. So under each section we'll have a box.
Okay.
This You can write in pencil as far as I know.
Yeah. Okay. They give you the option.
Right.
They tell you to write in pen at first, but then you ask if
Why don't they have us write essays in pencil? My life is
because it smudges.
I imagine with writing,
It's hard to scan it in too,
Really?
because it's
No,
like
no,
it's
everybody's
No.
I don't know.
Yeah. See.
Okay,
I just want to type it. Why do I have to handwrite it?
I don't know. Points on this one. Let's see.
Probably 2 points.
What? This is actually 3 points.
For what?
Yay for this section. You get 1 point for finding the slope, so knowing it's -16. You get 1 point for the tangent line, and you get 1 point for the. That is a very generous FRQ. So that's nice. All right. Use the second derivative to determine overestimate or underestimate. Explain to me why we would need the second derivative when we're dealing with a tangent line approximation.
Concavity.
Okay, and concavity is going to tell me what?
Whether it's overestimation or underestimation.
Okay, concave down will be a,
Overestimation.
concave up will be,
Underestimation.
okay. So if we go and find our second derivative, the second derivative on this is quite easy, right? So keep in mind, you are doing implicit differentiation. Because when you're taking the derivative of this, we need to deal with the second derivative. Okay, so what did you get your second derivative to be?
-1/4.
But is that wrong? Because we
dH dt. So we are taking the derivative with respect to h, or the derivative of h with respect to t. And so when I take that derivative up top, the second derivative of this, it will be -1/4 dH dt. Okay? And so now what we need to do is to determine where this is greater, or whether this is concave up or concave down. So this is my second derivative, sorry.
I'm just trying to think of it through the steps. Like, where does it come over from? At what point?
This doesn't come over. You're taking the second derivative, so we're doing it implicitly. It's just like if we had like the derivative, like if we had xy equals 5, and we take the derivative of this, and we want to find dy, the derivative with respect to x. When I do the product rule, the derivative of x is just 1 dx dx. We don't normally write that. Plus, or times the second, plus the derivative of the second, which is dy dx. Same thing here. I'm taking the derivative of not h. I'm taking the derivative of h with respect to t. So that first derivative needs to have that. Does that make sense? Okay. Erase that because that's not part of it. Okay. It is still concave down. So I'll explain, since some of you got this. dH dt was -1/4 h minus 27. So this is what this expression looks like. So we get the second derivative with respect to t is 1/16 h minus 27. Okay, so.
Oh, right.
Yeah?
Thank you.
Okay.
Whoever said that.
So at t equals 3, well, let's think about the value of this function. What does this graph look like? Negative.
like that. No. Wait. Would it be
Like this. No, it's
Concave down, or no?
It's actually concave up.
It's because we didn't add the DHDT thing, which messed us up.
No, that.
The second derivative.
Oh, yeah.
When will this function be positive, and when will it turn negative? Meaning, what is its, where is it equal to 0?
It's going to be
H
positive
equals 27.
at h equals 27 or more? Or no, well, 28 or more, yeah.
28 or more, it will be positive.
Then less than.
So it'll be negative below. So this graph, oh, I don't like their answer, actually.
Uh-oh.
I don't get it.
Yeah, it's t equals 3.
Yeah. Yeah.
So when you plug in 3,
Okay.
doesn't it do positive times positive?
Okay.
You can't plug in 3 to H because
We can't plug in 3 to
But
H.
you have H's.
Okay.
We have time which is my sorry.
So 43 minus 27 is a positive times a positive would be concave up. So an underestimate?
41.
This is an underestimate.
Oh, the 43 there.
The 43 that you
Yeah,
because you already
yeah.
solved for T equals 3.
And then
Yeah,
there's
that
maybe
makes
one where like the mistake.
Are all
Yeah.
concave downs
So then one fix
underestimated?
that one.
Concave, no, concave ups are all underestimates.
Any like.
Wait, but isn't it concave down?
Uh-uh.
No.
It's concave.
Yeah, so
We
this
were-
is
Okay.
an underestimate.
Oh,
Yeah.
because you have to plug it.
So,
You're close.
Wait, Miss Alice.
say that again.
You're literally the opposite.
What's the answer they have?
I actually like it now. It is underestimate, and I see why. Sorry, I was looking for the, yes, we're good. Okay. This function is when h is greater than 27, t will be greater than 0. Correct? Sorry, f double prime, the
When t
second
is greater than
derivative
0,
will be greater than 0.
Yeah.
Okay? Talk to me about what we know about this function at t equals 3. H is 43. Okay? So on this, when h is greater than 27, this second derivative is greater than 0. Meaning it's concave up. Correct? What we're looking at, when t equals 3, we know h equals 43, and 43 is greater than 27, correct? So therefore, this graph has to be concave up because it is positive. The graph is greater, the second derivative would be greater than 0 there. And since it's concave up, this will be an underestimate. Here's the good news on that. Do you want to know what the points are on this one? 1 total point.
I like how the
That
first one
is
is
so sad.
And then there's like 4 parts and it's 1.
Okay, here's what they're expecting, and probably where you're going to miss the points on this is one, the implicit differentiation. When you take the derivative of something that's a derivative with respect to a variable that's not in the function, we're taking the derivative with respect to t, but the function has an h in it. So we need a dh dt in there. So we're taking the derivative. And if it helps you to not think about it as like a multiplying, this dh dt is negative 1/4 h plus 27/4, whatever you want to look at it. It's linear, right? If we take the derivative of this with respect to t, it means anytime I take a derivative, it needs to include the t in it. So yes, the derivative of this is only negative 1/4, but we need that dh dt because I'm taking the derivative of h with respect to t. Probably that's where most of us will miss that if we're not paying attention to what we're actually using to take the derivative of. I had to wrap my head around the h is what we were looking for to solve for, not the t, to determine the overestimate and underestimate. This is a good question. But you can see why it might have inspired some
What's weird is
frustration.
Really anything on like the actual equation for Newton's cooling.
No, it is Newton's cooling, but it doesn't ask you to, it's just asking you to use it.
That's kind of a relief. But
Yeah.
Like,
Yeah,
like,
one
you
less
think-
equation to remember.
So our original equation is like, for this is the second derivative is equal to negative 1/4 the first derivative.
Yes.
And then for all of it, we're relating t equals to 3. So could you have gone up and found, from part A, we said that, for the derivative at t equals 3, it's equal to negative 16, and just plug
Yes.
that negative 16
Yes.
and gotten a positive number.
Yep. Yeah, great question. So could you have gone and used, I'm just reading because I'm recording it. There you go. So could you have used the fact that at t equals 3, we know the slope at that line is, at that point is negative 16 from part A. And instead of substituting in the whole function and thinking about where the function is greater than 0, substitute that value in and see if it's positive, negative. And the answer is yes, you could absolutely do that. And you would see that it's positive, therefore concave up, therefore underestimate. Exactly what you could have done. Yep, that would have been another way to do it. All right, 1 point there, so that's nice. Okay, part C, and this is probably where most of you spent most of your time once you got going, just because it requires a bit more work. For T is less than 10, an alternate model for the internal temperature of the potato at time T minutes is the function G. This satisfies the differential equation where G of T is measured in degrees Celsius and G of 0 is 91. Find an expression for G of T. Based on this model, what is the internal temperature of the potato at time T equals 3? Ready? The good news is, or bad news, I'm not sure how you look at it, this section will be worth a lot of points because we've only had 4 so far, right? Mm-hmm. So this will have more points. Okay. Here we go. So first thing we'd want to do is we need to take this new function and we will need to rewrite it. Separate it. So I need to take the antiderivative. So I'm going to have 1 over g minus 27 to the 2/3 dg equals negative dt.
So why do we leave the negative on the...
You don't have to, but we typically will take as little with us as possible.
Okay.
I'm going to take only what's necessary, and since I don't need to bring the negative over because then we deal with chains in there that I don't want to have when I'm integrating,
Yeah.
I'd rather leave it on that constant side with dt.
Okay, that's right.
Good question. I'm going to integrate both sides now.
You do have to separate it.
You do need to separate it. I don't know how you would... I'm not sure how you'd integrate it otherwise. You might be able to get it. No. I think you would lose a c. I think you would lose where the c belongs. Okay. If we integrate this, this is really like saying g minus 27 to the negative 2/3. So we're going to go up a degree. Up a degree would put me at 1/3. Divide by that degree, which would be the same as multiplying by 3, equals negative t plus c. And we know that g of 0 equals, where did it say that? 91. So I'm going to substitute that in. So I'm going to do 3 times 91 minus 27. I heard you guys complaining about your subtraction skills. It's okay. We can do it. 91 minus 27 is 64 to the 1/3, and the cube root of 64 is 4. So we have 3 times 4 equals c. So c equals 12. And so my equation, g of t, what did it ask me to find?
I want you to find out...
A model. Based on this model, find an expression for g of t. Okay, this gets a bit messy. So we get 3 g minus 27 to the 1/3 equals negative t plus 12. So I would divide by 3. So we get g minus 27 to the 1/3 equals negative t plus 12 over 3.
Why are you waiting to plug in t?
You can't leave it like how it was before. You have to...
If they ask for an expression that explains g, I think they're going to want you to get g by itself.
Makes sense. I thought you were plugging in t. I thought this was your finding t equals 3.
No. This would be cube root of negative t plus 12. I don't know that I like it in that order because of the negative, but that's fine. And then add 27. So g equals the cube root of negative t plus 12 over 3 plus 27, which is outside of that.
Isn't it cubed?
Oh, yeah. Oh, my gosh. You guys. I didn't get enough sleep, apparently.
It's okay.
Okay.
I was a little bit...
Thank you. Blindly following me, just not saying anything.
I was just working.
We
I
wait
was
for you to be
confused.
done.
I
just never wrote it. I just plug stuff in.
Cubed. It makes it prettier. Not much, but it is cubed. Yes, it is cubed because 1/3 the undoing of that would be cubed. Yes. So based on this model, what's the internal temperature of the potato at time t equals 3? So then we're just going to plug that in. Negative 3 plus 12 over 3 to the 3rd plus 27 So we get,
You're about 9. You already did it in your head.
oh,
Good job.
thank you.
Way to be ahead of the game.
Whew. Okay, so 9 divided by 3 is 3, cubed plus 27. So we get 54.
At least we got the answer right.
Every time
Yeah,
I
we
tried
did
to
get
write.
the equation.
Okay, so there's going to be a lot of points on this one because we've only had 4 so far, which means this one part has 5 points. So let's see where they are. Hopefully.
Get one.
Okay. 5 points.
She told me that it was 5
I thought it would be 5 points.
Total.
Not.
It is 5 points.
No, like everything.
Oh, no, it's 9 points. Total. Okay.
Are most FRQs 9?
All FRQs are 9.
I have, and I thought this was like the 8
Okay.
part.
5 points. It is 5. First, if you know to separate your variables, you get a point for separating your variables.
Okay, cool.
You get a point for your antiderivatives.
Okay, 2 points.
That would include,
What if you don't separate the variables, but like take the right antiderivative? Just have the wrong thing.
so you would lose a point for that separation of variables.
But you could get a point for the antiderivative.
Okay. You get a point for this next one says constant of integration and uses the initial condition. So that would be somewhere somewhere in here, something like that step. But here's what they say. Note, max 2 out of 5 possible if no constant of integration is present. So if you forgot your constant of integration, the most you can get is 2 out of 5.
Because you'd only get to separate and
Yes.
Wow.
Okay. Equation involving G and T. So meaning you get some equation. So let's say you didn't go and solve for G by itself. So if you got here, you would get a point. But the next point says G of T and G of 3, which leads me to think that if you get this and this, you get a point. So if you miss one of them, you lose just a point. So these are like connected.
The anti part means you get a point for taking the antiderivative.
Yeah, I didn't finish writing derivatives.
I just wanted to make
Oh,
sure
so
that's
that's
all.
good. So like even if you don't separate it, you could technically get.
Yes.
Then it's 1, 2, 3, 4, 5, 6.
That's good.
What do you think?
If you get the
They're
54.
very
Wait, no, we get
flexible.
points.
These things are like
Yeah, but like
Yeah, and
all that
and that will
works
depend on your reader and how many partial